Okay, so it's often that, when you switch over from computational mathematics to theoretical mathematics, you can ask yourself, you're like, oh my gosh, this is so much more difficult. I'm so used to computation. Why do you want me to do things? Why do you want all these details? And so I like to give an example on the first day of any class, which is one of the kind of like first courses where you're actually proving things, to give an example of how our intuition is not always correct. So here, and it's much better if I can get you to play the game with me, but you're just going to have to bear with me. So here we go. So I'm going to start with this circle, and I'm going to just put one dot on it. And there's only one dot, so if I was to say I'm going to connect any two dots by a straight segment, they'd say, okay, well there's only one dot, so there are 0 segments, and then I'm going to look at the regions that are left in here, and I'm going to see one, right? I see one region here. Okay, so I have one complementary region. Okay, and I'm going to keep on going with this game. That might be hard with all those other dashes to see. There's a 1 that I put in there. Okay, now let's go ahead and continue this game. So I'm gonna make a circle, and I'm gonna put 2 kind of equally distant, so they're gonna actually be antipodal points there on the circle. But now I can connect these with a line segment, so I'm gonna do that, just like that. Okay, and then if I look at the complementary regions again, okay, so now I go 1, 2, so I have 2 complementary regions. And then I'm going to keep on going. Okay, so now I can, if I connect all these up, I get a triangle, right? And I'm going to go 1, 2, 3, 4, so 4 complementary regions. Okay, I'm going to keep going. Now it starts to get a bit more complicated. What I'm actually doing is I'm forming the complete graph on those vertices. But okay, so I'm going to keep counting. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. You may already think you're seeing a pattern. Okay, so we'll keep going and see what you think. So now, right, I'm going to do 5 of these. So I'm going to do the complete graph on 5 vertices. I did not do this the most efficient way. Sorry about that. There we go. Okay. So now we're going to count. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 complementary regions. Right? And then by now, if you're good at patterns, you're looking at this and you're going to tell me, what's running through your mind is we're getting powers of 2, right? This is the 0th power, the 1st power, the 2nd, 3rd, 4th power of 2. So if I keep going, you're going to assume, right? So far it looks like 2 to the k minus 1 for k dots. Right, 1 dot and 2 to the 0th is 1, and you can keep on going through and check and see that you believe that. Okay, so then here we go. So now I'm going to take a circle, and we're going to go 1. So if it looks like this, then you're going to tell me, like I'm good at pattern recognition, I can do this. This should be 2 to the k minus 1, I have 6 dots, so 2 to the 5th, this is surely 32. And now you're actually going to watch me go through this whole thing to show you that it's not. There's also a question as to how nice I can draw this, but you could get a computer too to tell you if you're unsure, if you don't believe me. Okay. So now we check, if you want to make sure you have all the lines, you check that each of these vertices has the same valence, so the number of lines coming out of them. So 1, 2, 3, 4, 5, which would mean 1, 2, 3, 4, 5. It hits all the others. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so now we start our count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh, I bet you that one's not supposed to be there. 17, 18, 19. We'll decide. Either way, we're not gonna get the correct number. 23, 24, 25, 26, 27, 28, 29, 30. That one I think is artificial, but you could see that even if I put that one in, I would have gotten 31, which is less than 32. But if I'm remembering correctly, there are none that small. It should be 30. Oh. It's just kind of, we're living in a different world where they are like that. Okay. Anyway, so this is so we actually get 30, not 32. Okay, and I feel like this is one of these very cute, nice examples of something where, you even, like, by the time you did 5 cases of this, like, this is one of these things where I think, like, even I would look at that and be like, yeah, that's probably true. It's probably 2 to the k minus 1. Even with all my years of mathematical experience, I would probably still say that. And so it's kind of this nice example, and also when you can show your friends. But it tells you why, your intuition can lead, like, it can inform, like, it can give you the hypotheses as to what you think is actually going on, but you should always actually prove it to make sure that you can use it in all circumstances and so on, and not worry that something like this is going to happen.